Hello and welcome to RDL's Analog Audio Basics Review. In this presentation, I'll review the basic fundamentals of analog audio, the RDL products you'll need to properly design and support your installation projects, and the important role analog audio plays in today's systems. As you know, there are many types of audio signals, various signal levels or strengths, and different cables and wiring types that are used for a variety of applications. I'll review the most common types we use in the commercial audio industry, their different levels, features, and benefits, and their correct applications so you'll have a better understanding of how and when to use them. This understanding will also help make it easier for you to choose the right RDL products for your system designs. To fully understand the differences between signal levels or signal intensities, you should first have a basic understanding of signal levels and how they're measured. I'll start with what we hear. When we reference changes in natural sound intensity, also known as volume or sound pressure levels, we use a scale called decibels. Decibels, represented by the symbol dB, is a logarithmic scale that's based on perceived sound intensity. Unlike common linear scales, which have uniform units of measurement, such as feet or meters used to measure length, logarithmic scales multiply their units of measurement by a particular factor to display a wide range of values in a smaller, condensed way. This is especially useful when it comes to our hearing, as our ears perceived increases in sound intensity at a significantly lower rate than the amount of energy used to produce these increases. For example, an average conversation produces a measured sound level of 70 decibels. If we compare that to a sound level that measures 10 times higher, or 80 decibels, such as the sound produced by a passing bus, our ears will only perceive this increase as twice as loud, not 10 times. Therefore, a sound that measures 90 dB would only be perceived as twice as loud as 80 dB. Yet it takes 10 times the energy to produce a sound level measured at 90 dB than at 80 dB. This logarithmic decibel scale plays an important role in the audio electronics world. For example, when designing a sound system, you have to decide how loud a sound system needs to be for that particular venue. It's helpful to understand that doubling the total amplifier output, or watts, will only be perceived as a mild increase in volume level by the audience. Decibels have an equally important role with the relationship to audio signals. In the early days of audio electronics, ideal ranges of signal levels, or signal strengths, had to be identified in order for manufacturers to produce compatible audio electronics. One primary obstacle to consider was the noise floor. The noise floor is the inherent unwanted noise produced by all audio electronics. Fortunately, these electronics produce noise in a fairly low range of signal levels. To provide clean, clear audio with enough variable level space to produce realism, a much higher range of levels would need to be used for our audio signals. This higher range would need to provide a desirable distance or separation from the noise floor, yet it couldn't be so high or so powerful that audio signals would exceed the limits of the audio equipment inputs. The analog audio inputs of professional audio electronics typically have a peak input signal limit of plus 24 dBu. It was decided that professional audio equipment should produce average signal levels at plus 4 dBu, which leaves 20 dB of space for higher fluctuations in signal levels, which we call headroom. Consumer audio equipment produces signals a little lower in strength. For professional and consumer audio equipment, we have two reference scales. Although it's not an exact match to the decibel scale, analog audio signal levels are measured in units using decibels referenced to the signal's voltage. The two most common reference scales are dBu and dBV. These scales reference a different voltage level for the respective zero levels. The dBu scale uses a reference voltage of 0.775 VRMS, whereas the dBV scale uses a reference voltage of 1 VRMS for a zero level. Again, these scales represent two different groups of electronics. dBu is commonly associated with balanced signals, typically used in professional and broadcast equipment, such as microphones, mixers, and signal processing equipment. dBV is commonly associated with unbalanced signals, typically used in consumer electronics, such as media players, smart devices, and home theater equipment. In commercial audio, the three most common levels of signals are microphone, line, and speaker levels. Speaker levels are post-amplifier and can vary greatly depending on the power of an amplifier. This chart represents mic and line levels, which are the signals used in audio electronics before amplification. I'll start with the lowest or weakest signal level and work up to the highest. Microphone level, often called mic level, is the lowest signal level that we use. As the name suggests, it's a very low voltage signal generated by a microphone, which converts sound waves into an electric current. Mic signals typically range between -60 to -40 dBu and have to be amplified with a preamplifier, which boosts or raises the signal level up to line level, which is the signal level range most audio electronics operate at. A quick note, there are two primary types of microphones, dynamic and condenser, that have special requirements. Dynamic mics are passive, meaning they don't require any electrical power to operate. Condenser mics are active and do require DC voltage called phantom power. Phantom power is provided by the various electronic devices that microphones connect to, such as standalone preamplifiers, audio mixers, and DSP units. These electronics inject voltage onto the same cable the microphone uses to send audio to that device. Although specialty microphones can require higher or lower voltages, phantom power is typically supplied as 12, 24, and 48 volt DC, where these voltages are often represented with just a V for voltage or the symbols P12, P24, and P48 respectively, where the P stands for phantom. The next level up is line level. Line level signals are the highest level audio signals that still need to be amplified. These signals flow through all of the audio electronic devices before reaching an amplifier that powers your loudspeakers, which are typically just called speakers, or headphones. This applies to both pro and consumer audio systems. To help differentiate between pro and consumer products, you might see +4 dBu or -10 dBV listed on various product spec sheets. These are the nominal levels or ratings that signify the audio input and output levels a particular electronic device uses. A nominal level of +4 dBu indicates the device uses line level signals that are higher in strength, like those found with professional equipment, which are typically balanced signals. A nominal level of -10 dBV indicates the device uses line level signals that are lower in strength, like those found with consumer electronics, which are typically unbalanced signals. Because of the variance in signal strengths between consumer and pro electronics, you may need to use attenuators, which lower signal levels, or line amplifiers, which raise signal levels, if both pro and consumer electronics are to be used in the same system. The third and highest level signals are speaker level. Speaker level signals are post-amplification, meaning an amplifier is used to elevate or boost a line level signal to a strength needed to power speakers or headphones. Available in a variety of power levels from very low to high, specific amplifiers are chosen to support each audio system's needs. Therefore, speaker level signals can be very high in voltage and require specific cables for transferring these signals. The two primary types of speaker level signals are low impedance and constant voltage. I should note that how we refer to a type of audio system is often dictated by the speaker level type. For example, if a system's amplifiers output low impedance signals, the audio system may be referred to as a low impedance audio system, which is also known as a low Z or direct coupled audio system. In a low impedance audio system, typically only one or two speakers are directly connected to each amplifier output, and cable runs are limited to 200 feet or 61 meters. However, longer distances have been achieved under the right conditions. As cable distances increase, heavier gauge wire is needed to help minimize signal loss. This chart provides practical cable distances you can use based on the average wire gauge. Low impedance systems can support speaker resistance loads from 2 to 16 ohms, with 4 to 8 ohm systems being the most common today. The benefit of low impedance systems is that they produce an accurate full range frequency response, so they're commonly used for audio systems such as foreground music, live sound venues, and residential hi-fi or home theater systems. The second speaker level signal type is constant voltage. Audio systems that use constant voltage amplifiers are typically called constant voltage speaker systems, but may also be known as high impedance, distributed speaker, 100 volt, 70 volt, or 25 volt speaker systems. Constant voltage systems can distribute audio signals over long distances to many speakers, and in many cases with relatively low power requirements. Constant voltage amplifiers use transformers to step up the voltage of the audio signal to either 25, 70, or 100 volts. This minimizes power loss over long speaker cable runs. The connected speakers each use step-down transformers, which reduce the voltage to a usable level. These step-down transformers have adjustable settings called taps, which limit the watts they pull off the system. You can easily calculate the audio system's total impedance by adding up the collective tap settings from each speaker. Constant voltage amplifiers can support any number of speakers as long as the amplifier's maximum power or total wattage is not exceeded. These systems are ideal for voice and low-level music applications such as paging and background music. Now that we've covered the basics of signal levels, let's review the difference between balanced and unbalanced signals and the wiring, cables, and connector options associated with each one. First, understand in any system there can be a variety of signals and connectivity options. The audio circuitry in one device may be designed to specifically use either balanced or unbalanced audio signals with a particular connector type. Other devices may support both types of signals and offer multiple connector types. Therefore, an audio interface might be needed when two or more devices with different signals and connector types are used in the same system. Let's start with balanced audio signals. Similar to an antenna, audio cables are susceptible to noise caused by electromagnetic interference, which includes ground noise or hum, and the longer the cable, the greater potential for induced noise. Balanced signals, which can be mic or line level, have great immunity to noise and interference. So how do they do this? First, each balanced signal requires a pair of wires, which are typically twisted together. The sending circuit or output of the audio sending device duplicates an identical audio signal onto both wires. Plus, it reverses the polarity of the second signal, making it 180 degrees out of phase from the first. This is recognized as differential signaling. The receiving circuit or input of the audio receiving device has a differential amplifier which measures or responds to the differences in voltage between these opposing signals. Now, if any noise is induced onto the two wires, the noise will be identical and in phase in both signals. This is recognized as common mode signaling. Since the receiving circuit or input of the audio receiving device only responds to differential signals, the common mode noise is canceled out, leaving a clean, clear audio signal behind. This process is called common mode rejection. For wiring identification, the first balanced signal wire or conductor is commonly referred to as positive or hot and may be represented with a plus symbol. The second wire with the out-of-phase signal is called negative or cold and may be represented with a minus symbol. Although it's common to see a third conductor for signal ground in balanced cabling, which could either be a wire or a shield in the form of braided wire or foil, it isn't always required in a balanced circuit. And in fact, the signal ground may only be present on the receiving device or not at all. So you're aware there are two different balanced circuits that are commonly used in today's electronics. The first is a floating circuit, where truly floating balanced signals have no connection or relationship to the signal ground. This is achieved with transformer isolation, which we'll cover more later on in this presentation. The second is an electronically balanced circuit, where balanced signals do have a relationship to the signal ground and are sometimes referred to as grounded balanced signals. Some common balanced connectors are XLRs and quarter-inch TRS phone jacks. TRS is an abbreviation for tip, ring, and sleeve. Although less commonly used, XLR and TRS connectors could be wired to carry unbalanced stereo audio signals, where the audio is split into left and right signals traveling down the positive and negative conductors of an XLR connector or the tip and ring conductors of a TRS connector. Unbalanced stereo signals do not provide common mode rejection and are susceptible to noise and interference, especially with long cable runs. Bare wire connections are very common in commercial audio today. The three standard connectors used are solderable connectors, which allow you to fuse wires to each device, screw terminals, which provide locking screw clamps, and removable terminal blocks, which are similar to screw terminals yet detached from their devices to help simplify the wiring process. Removable terminal blocks are also known as Euro blocks or simply terminal blocks. So how long can a balanced cable be? This depends on several things. For balanced mic level signals, practical cable lengths can vary depending on the type of microphone used. The signal from a dynamic or passive mic could easily run up to 100 feet or 30 meters without any issues, and the signal from a condenser or active mic could easily run up to 200 feet or 61 meters without issues. Theoretically, longer distances can be achieved, but too many factors come into play for us to cover in this presentation. Practical cable lengths for balanced line level signals also depends on many factors. Balanced line level signals could easily be run up to 2,600 feet or 800 meters under the right conditions, such as using higher +4 dBu signal levels with quality shielded cable and the correct gauge of wire. Again, theoretically, longer distances can be achieved, but too many additional factors come into play for this presentation. Unbalanced line level signals require two wires, one for the signal and one for ground. Also similar to an antenna, unbalanced cables are susceptible to attracting unwanted noise and interference along the way. However, unlike with a balanced signal, there is no common mode rejection to cancel out the noise. Therefore, unbalanced cables are typically used for very short distances, which helps minimize the potential to induce noise. Because of these limitations, we recommend cable lengths of up to 10 feet or 3 meters. Although longer distances can be achieved and much longer pre-made cables are available, maintaining a clean, unbalanced signal will require extremely favorable conditions and a lot of luck. Unbalanced wiring and cables are commonly associated with consumer equipment, which typically requires very short cable runs between devices. Some of the more common types of unbalanced cables and connectors used today are mini jacks, also known as 3.5 millimeter or 1/8 inch jacks. This is a 3-conductor tip ring sleeve connector that provides left and right channels plus ground. RCA jacks provide mono signals only, so a pair of RCA jacks are required for stereo applications. And our third connector is 1/4 inch TS phone jacks, where the TS is an abbreviation for tip sleeve. Although it's not a type of signal, shielding is a feature that provides a barrier to help insulate the wires and audio signals from unwanted noise and electromagnetic interference. Shielding can also reduce electromagnetic radiation, which is noise that may be released from the cable to interfere with other devices. For these reasons, shielded cables are typically used with unbalanced signals. A shield may be made of braided strands of copper or aluminum wire, a spiral wrap of copper or aluminum foil, or it could be a layer of conducting polymer. The shield is then usually covered with an external jacket, which is a protective outer sheath typically made of plastic or rubber. The shield itself must be grounded to be effective and should be electrically continuous to maximize its effectiveness, with extra attention and care given to cable splices. Shields can be used as the return path for the signal or may act as protection only. Earlier I mentioned transformers being used in constant voltage systems to step up and step down voltage. The Merriam-Webster Dictionary defines a transformer as one that transforms, specifically a device employing the principle of mutual induction to convert variations of current in a primary circuit into variations of voltage and current in a secondary circuit. In simpler terms, a transformer is an electrical component with two or more wound coils of copper wire placed closely to each other. These coils each produce a magnetic field. The coils transfer electric energy from one circuit to another through the magnetic fields, which is called magnetic induction. Transformers are typically used to either change or filter out select characteristics from one circuit to the next. All transformers are passive, meaning they don't require electrical power. However, some transformer products may require a power supply to support any additional electronic features they may have. Transformers are produced in many different sizes and strengths, which makes them extremely useful for a variety of applications and industries. Here are some examples of how audio transformers are used. They can eliminate buzz and hum caused by electrical current ground loops, which are typically found at 50 or 60 hertz or cycles. They help block radio frequency interference. They can be used to provide impedance matching between high and low impedance circuits. They can be used to convert balanced signals to unbalanced, or the other way, unbalanced to balanced. And specialty multi-winding transformers can be used to split or combine signals. When it comes to audio transformers, the design and careful attention given to the windings of the coils directly correlates to the maintained sound quality. Poor quality transformers can reduce or limit low and high frequencies and add harmonic distortion to signals. RDL's transformers maintain extremely high signal quality and are ideal for use in broadcast and high-end recording studio systems, as well as all other commercial audio applications. These transformers are from our TX series, which are great for signal conversion. The TX-A2 converts balanced signals to unbalanced. It has a mono-balanced input on terminal block and dual mono-unbalanced outputs on RCA jacks. This transformer essentially converts professional plus 4 dBu signals to consumer minus 10 dBV signals. The TX-A2D has the same functionality as the TX-A2, except it has a balanced stereo input and unbalanced stereo output. The TX-1A also converts balanced signals to unbalanced, but uses terminal blocks for connectivity, and it provides signal level reduction from 4 to 24 dB. The TX-J2 converts unbalanced signals to balanced. It has dual RCA jack inputs and a terminal block output. This unit is great for hum cancellation on unbalanced lines. These two transformers convert speaker level to line level. The TX-70A converts constant voltage 2570 or 100 volt speaker levels to unbalanced line level, and the TX-8A converts low impedance 4 ohm or 8 ohm speaker levels to either balanced or unbalanced line levels, and supports speaker levels up to 400 watts. Both of these allow you to add on or extend an audio system without having to replace any existing equipment. For example, you could extend a background music or a paging system by adding a small amplifier instead of replacing the existing one with an expensive larger unit, or you could use these transformers to add a powered subwoofer to a system. Here are some hum killers, which are transformers used for removing ground loop noise or hum in a signal. The AVHK1 is a stereo hum killer with unbalanced inputs and outputs on RCA jacks. The AVHK1X is a mono hum killer with a balanced XLR input and output. And the EZHK1 is a stereo hum killer with unbalanced inputs and outputs with a choice of either dual RCAs or mini jacks. Audio mixers and combiners primarily blend two or more audio signals together, but there are differences between them. Combiners are typically designed to merge 2 to 4 audio signals together without providing any other options to modify the signals. The product designs are less complex, which makes them a cost-effective solution if only this one function is needed. Here are some combiner examples. The TX-J2, which you saw several slides ago for converting unbalanced signal to balanced signals, is also a combiner which combines stereo signals to mono. The TX-LC2 also combines and converts unbalanced stereo signals to balanced mono, but adds a gain trim feature. This allows the signal level strength to be lowered by up to 10 dB or increased by up to 10 dB. This combiner is active, which means it requires 24 volt DC power. The primary function of mixers is to blend multiple audio signals. Mixers can be designed to support anywhere from 2 to an almost infinite number of audio signals and offer a broad range of additional options and features to modify audio signals individually and collectively. Although there are many, here are some of the more common features found on mixers. Gain. Gain is used to adjust or trim the levels of inbound mic and line level signals. Equalization, also known as tone control, is used to adjust or balance multiple frequency levels. Pan, this is for stereo mixers only, is used to position a mono signal in a stereo field by adjusting the levels of the signal's left and right channels. Inserts, this is the connectivity used for routing signals to and from external audio effects devices. Level, also known as volume, is used to adjust the levels for individual and combined outbound signals. Here are several mixer examples from our Rack Up, Easy, and Flatpack series. The RU-MX4 and RU-MX4T are both 4-channel studio quality mono mixers. They support mic or line level inputs and outputs on both RCA jacks or XLRs. They have selectable phantom power per channel. They have a switchable compressor limiter and dedicated direct input, which allows you to link multiple mixers together. The T version adds an isolation transformer. The Easy MX4L is a 4-channel stereo mixer. It has unbalanced line level inputs and outputs. On channels 1 through 3, the inputs are on dual RCA jacks. On channel 4, you have a choice of mini or RCA jacks, as well as mini or RCA jacks on the output. The FP MX3R is a 3-channel remote-controlled mono mixer. It supports balanced or unbalanced inputs and outputs, has adjustable gain controls, and this unit requires a 2 or 3-channel VCA remote control. Here are 3 mixers from our small stick-on series. The ST-MX2 is a 2-channel mic or line level mono mixer. It has adjustable gain on each input. You can use both mic and line output simultaneously, and it has a dual LED view output meter. The ST-MX3 is a 3-channel line level mono mixer. It has adjustable gain on each input, and you can use it to combine unbalanced or balanced signals. The ST-UMX3 is a 3-channel mic or line level mono mixer. It has selectable mic or line inputs and outputs, adjustable gain on each input, and a dual LED VU output meter. Audio distributors, also known as distribution amplifiers or DAs, duplicate input signals into 2 or more identical yet isolated output signals. This function allows one signal to be distributed to multiple destinations for a variety of purposes without inducing unwanted noise or signal degradation. Some distributors may include input and output level adjustments. Since signal level strengths can decay over long runs, individual output level adjustments are especially useful to balance the final signal levels at their destinations. Distributors can be designed to support mono or stereo signals, balanced or unbalanced signals, or both. Here are some distributor examples from our Rack-Up series. The RU-MLD4 is a 1x4 mic or line level audio distributor with 4 mono outputs. The front panel has XLR inputs and outputs, and on the rear panel there are additional inputs and outputs on detachable terminal blocks. This unit has several switchable features including microline input, mic gain, and phantom power, and there's a gain trim on the input. Each output is switch selectable to either mic or line level. The RU-88-8D is a 2x8 line level audio distributor with 8 stereo outputs. However, there's a selectable mono operation that allows this unit to be used in mono mode, which provides a 1x16 or 16 mono outputs. The front panel has input and output level trimmers, and all inputs and outputs are on detachable terminal blocks on the rear panel. Here are 2 distributors from our Stick-On and Easy series. The STDA3 is a 1x3 line level distributor with 3 mono outputs. It supports balanced and unbalanced inputs and outputs. All connections have RF protection, and there's an adjustable gain function. The Easy ADA4 is a 2x4 line level distributor with 4 stereo outputs. It has unbalanced inputs on both RCA and mini jacks, and has RCA jack outputs. Audio switching is the process of selecting one audio signal from 2 or more sources to connect to one destination. This is similar in concept to a railroad switch. 2 trains on separate tracks are wanting to merge onto a single track. The railroad switch at the junction only allows one train to drive onto this track at a time. An audio switcher plays the same role with multiple audio sources. Switchers typically support anywhere from 2 to 8 audio sources. They can be designed with physical selector buttons on the unit itself, or designed to be remotely operated from a remote control, or both. They can support either mono or stereo audio signals, as well as balanced or unbalanced signals, or all the above. Here are several switcher examples. The ST-SSR1 is a 2x1 line level switcher. It supports balanced and unbalanced inputs and outputs. The switching function is fast and silent, which is ideal for audio muting. This unit requires a remote control with open collector logic to operate. We'll cover remote controls in more detail later in this presentation. The EasySX4 is a 4x1 stereo line level switcher. It has unbalanced inputs and outputs on RCA jacks on the rear panel, and source selection and level control on the front panel. The RU-ASX4D is also a 4x1 stereo line level switcher. This unit has source selection on the front panel, or it can be remotely controlled. On the rear panel, it supports balanced and unbalanced inputs and outputs on removable terminal block, and gain trim is provided for each of the source inputs. Routing is the process of selecting a signal path between one audio source to one of multiple destinations. This is also similar in concept to the railroad switch, but in reverse. Here, one train comes to a junction with 2 tracks leading to different destinations. The railroad switch allows the train to drive onto one selected track. A router plays the same role for one audio signal, where the signal can be connected to one of many destinations. Depending on the type of router, they can support anywhere from 2 to an almost infinite amount of destinations. Routers may have physical selector buttons on the unit itself, or be operated from a remote control, or both. They can support either mono or stereo audio signals, as well as balanced or unbalanced signals, or all of these. The SDRX2 is a 1x2 router that can send a balanced or unbalanced line-level audio signal to one of two destinations. These destinations are referred to as normal or default destination and a selected destination. The routing change is triggered by an RDL remote control or any controller that provides open collector logic. Here we're showing a DRC2ST 2-channel remote control as an example. Here's a system diagram to show you a common example of how this router could be used. In this facility, paging announcements need to be delivered to two separate rooms or zones independently. A microphone signal is fed into an STM2X preamplifier to raise the mic signal to line level. That line level signal is then fed into the SDRX2 router. The router's normal and selected outputs each feed two separate amplifier and speaker PA systems, one per room. A remote control is installed at the microphone station, which is used to select which room the page is sent to. Ducking, like the name implies, is an audio effect that automatically lowers the level of one or more audio signals when an additional signal becomes present. This additional signal is typically from a more important source than the others, and therefore has what's called signal priority. A good example is when background music is lowered so you can clearly hear a paging announcement. Depending on the device, ducking levels can be adjusted from a slight amount to fully off, and the response of the ducking action can be instant or gradual. When the priority signal has finished, the other signals are restored to their original levels. This restoration may be adjusted to happen instantly or fade up gradually. This function may also include an adjustable time delay feature. A time delay postpones the restoration of the other signals, which helps prevent false stops caused by temporary absence of audio in the priority signal. Silent pauses at the end of sentences are good examples of this. Properly delaying the restoration of the less significant signals produces a smoother listening experience. In addition to paging systems, ducking is also used for a variety of applications such as during live TV and radio broadcasts, in voiceover recordings for training and marketing applications, and even priority paging over standard paging, such as in emergency applications. Here are several ducking product examples. The STVP2 is a fully automatic ducking module that's ideal for background music systems with paging. The background signal is automatically ducked whenever a paging announcement occurs. There's an automatic gain control, or AGC, compression feature that automatically averages out the wide variety of signal levels received from background music programs and recordings. This AGC feature produces more constant or average background listening levels, which is more pleasant for the listeners. The next product is an HD MA35A 35-watt constant voltage mixer amplifier. It's one of the many mixer amplifiers RDL offers with a built-in ducking or Vox feature, making it ideal for background music with paging systems, as well as music on hold applications. The priority ducking feature can be set up for manual triggering or automatic operation. We'll cover more of this mixer's features later in this presentation. Equalization, often called EQ, is an audio effect used to adjust the levels of different frequencies or pitches in an audio signal. These adjustments alter the collective tone of a signal's sound to either improve its tonal quality, or to adapt it to a sound system with frequency limitations, or to help it blend in or stand out amongst other signals. Equalization is available as a standalone device called an equalizer or an EQ, or as an integrated feature in other electronics such as audio mixers and DSP units. More common equalizers are designed to adjust anywhere from 2 to 31 different frequencies. For example, tone control adjusts two wide ranges of frequencies called treble and bass. A 1/3 octave EQ provides 31 frequency adjustments commonly used to minimize rogue frequencies or to balance the overall frequency response in an environment. Other types of EQs, such as parametric, offer 3 or 4 adjustments where the frequencies and the size of their ranges are fully adjustable. Let's review 3 equalizers. The first is our ST-EQ3, which is an easy-to-use 3-band EQ. You can adjust the frequencies to effectively pass the voice band, which is great for narration and voiceover applications, or you could adjust it to produce a smile curve to emphasize high and low frequencies for music applications. The RU-EQ3 is also a 3-band EQ where the mid-range control is optimized for voice band adjustment, and the frequency adjustments are conveniently accessible to the user on the front panel. The FPP-EQ3 is a 3-band parametric EQ. Each of the 3 bands, or filters, can adjust a definable bandwidth range from a narrow 4/100ths of an octave to a wide 1.5 octave range. This adjustable range can be placed anywhere in the full audio spectrum from 15 Hz to 20 kHz. Each filter is switch selectable to either cut or boost the selected frequency range up to 15 dB, and since the frequency bands overlap, this unit provides the ultimate in EQ control. Compression is an audio effect used to reduce or control the dynamic volume changes in an audio signal. In almost every signal, audio levels raise and drop due to fluctuations in the content, sometimes mildly and sometimes drastically. Think of presenters who start out speaking softly, then speak much louder or yell closely into the mics when they're passionate about something. Consider the many different audio recording levels you encounter when listening to various pieces of music, or the very drastic increases in audio level when someone sneezes or coughs in front of a microphone or accidentally drops it. Compression can be used to reduce peak levels, which when reduced generates more consistent or average audio levels, which produces safer signal levels for audio electronics and a more pleasant listening experience for the audience. Compression is available in standalone units called compressors or compressor limiters, or can be integrated into audio devices such as mixers and DSPs. Compressors are traditionally designed for line-level signals. However, RDL does make 2 microphone-level compressors. I'll explain line-level compression first. This chart contains an audio wave file where varying signal levels are visually represented and are often called peaks and valleys. The left or first half of the signal is uncompressed, where you'll notice large signal variations. In the second half, compression was applied, which is, as you can see, reduced the larger peaks and valleys to more consistent or average signal levels. Compression provides several benefits. It can help prevent excessively high audio signals from exceeding the limitations of audio equipment inputs, which is called signal overload. Overload produces distortion called clipping. This prevention against clipping also helps protect against damaging audio equipment such as recording devices, amplifiers, and speakers. Controlled or average signal levels help overcome ambient noise and improve intelligibility during loud and soft speech levels. Another great benefit is that compressed signal peaks leave additional signal headroom available. This allows the overall volume level to be safely increased without clipping, which allows more of the amplifier's available power to be used. In other words, an amplifier with compression can produce higher average volume levels than equally sized amplifiers without compression. Different models of compressors are designed with many different features for modifying audio signals. The reason for this is there are many different types of signals which require a variety of applied compression features to be controlled properly. I'll discuss some of the more common features. The first is input gain, which is used to adjust the level of the incoming signals. Next is threshold. This is a defined position where signals above this point begin to receive compression. Signals below this point, or below the threshold, remain uncompressed. A ratio is used to define how much compression is applied. Some signals need a little, some need a lot. The attack is the speed at which a compressor responds to a signal after it exceeds the threshold. Some signals require fast responding compression called fast attack, such as with the sudden peak of sound generated by a gunshot in a Western movie. Other signals may require slow responding compression called slow attack, such as with the classical piece of music, where the symphony's audio levels slowly increase over time to a very high level. The release is the defined amount of time when compression is released from a signal after it drops below the threshold. Fast release, slow release, or somewhere in between may be used for a variety of signal levels. Another audio process often associated with compressors is a limiter. Limiters provide a specific signal strength limit, or a ceiling, for audio signals. They can be standalone units or integrated into compressors or other audio devices. The difference between a limiter and a compressor is that, to a varying degree, a compressor gradually reduces the signal after it exceeds the compression threshold, where a limiter stops the signal completely from exceeding its threshold. For this reason, limiters are often used more for protection than audio processing, as this hard limit will truly protect your audio electronics and speakers from damage. A compressor limiter uses both effects together to form the ideal combination of signal control and a barrier for equipment protection. All source signals can benefit greatly when compression is applied with the correct threshold, ratio, speed of attack, and release for each signal type. A correct configuration or setup will produce very natural sounding yet controlled audio signals. The wrong setup will produce very unpleasant artificial sounding results. Here's the challenge. Audio signals come from a large variety of sources and styles, including live presenters, video and audio conferencing, paging, audio and video playback content, stream music, and much more. A compressor that's adjusted for one speech or one music style will not perform well with other styles. Basically, every source and style needs to have individually configured compression. Although audio systems can be improved with fixed settings and from a traditional compressor or DSP unit, for optimal results, a trained engineer would need to be available to make constant changes to the compressor's features in order to properly support the variety of signal types and levels the average commercial system encounters. Unfortunately, this is not practical and in many cases not even possible. It would be very difficult for a trained sound engineer to make these continuous configuration changes quick enough to be effective, and these personnel are not typically on staff or available to oversee most commercial systems anyway. These audio systems are usually installed, adjusted once, and then left for the customers to use. For continuous compression support for multiple signals in any system, RDL developed an auto-adjusting compression circuit. This circuit carefully examines the various characteristics of each signal, applies an appropriate threshold, the proper ratio or amount of compression needed, and it adjusts the speed of the attack and the release. These adjustments are literally made hundreds of times per second. Only the input and output gain is adjusted by the integrator, and the auto-adjusting compressor does the rest. This product is the STCL2 from our stick-on series. It's a mono line level audio compressor limiter with fully automatic operation that adjusts the threshold, compression ratio, and attack and release. The limiter and the compressor work together to provide both signal and equipment protection. The only thing an integrator has to do is adjust the input and output gain, and the STCL2 does the rest. Plus, two units can be coupled together for stereo signals. Here's a list of additional products which include RDL's fully auto-adjusting compressor. For power amplifiers, we have the EZ-PA20, both the FP-PA18 and FP-PA18H, all three models of the FP-PA20 series, the FP-PA35, RU-PA40D, ST-PA18, and the TX-PA40D. We have a lot of mixer amplifiers with this feature, the EZ-MX-A20 and all 10 of the HD series amplifiers and mixer amplifiers. We also have some standalone mixers, the RU-MX4 and RU-MX4T. Unique to RDL, our microphone compressors apply compression to microphone levels the same way our auto compressors do for line level signals. If a preamplifier receives an overly loud mic signal, that signal can be distorted or clipped as it's amplified to line level. Although the distorted line level signal can then be compressed using a line level compressor, the distortion is now a permanent part of that signal. The advantage of mic level compression is that it prevents distortion prior to the mic preamplifier or mixer. It also provides consistent mic levels regardless of speech levels, allowing a variety of presenters to produce similar mic levels. And it improves low-level speech intelligibility, helping those who are soft-spoken or too far from the mic to be heard as well. Here are RDL's two mic compressors. The HR-MCP2 is a two-channel microphone compressor and preamplifier. Each channel will independently produce consistent output levels from any microphone. It will regulate a wide variation of microphone input levels up to 25 dB. It has XLR and terminal block inputs and outputs, where the outputs can be set to mic or line level. It has selectable 48-volt phantom power, and each channel provides 20 to 60 dB of adjustable gain control, a 15 dB pad, a low-cut filter, and LED compression and clip indicators on the front panel. The EZ-MCP1 is a single-channel microphone compressor. and it can regulate a wide variation of microphone input levels up to 30 dB. It has XLR input and output connectors and outputs a mic level signal. It has both an input gain and an output level adjustment. This model provides 24-volt phantom power, which automatically turns on or off when phantom power is detected at the output connector. Since this unit could be mounted in a discrete location, simply turning phantom power on or off on your DSP unit or mixing console will trigger the EasyMCP1's phantom power to turn on or off simultaneously. And this unit has LED compression and phantom indicators. Both of these mic compressors are compatible with hardwired or wireless microphones. For wireless mic applications, simply connect the wireless receiver's mic level output to the compressor so you bypass that receiver's internal mic preamp, which is vulnerable to clipping. Automatic level control, or ALC, is also known as AGC, which stands for automatic gain control. ALC combines signal boost with compression to provide consistent audio levels from signal sources that deliver a variety of levels. ALCs boost low-level signals as well as compress high-level signals to a set and desired average listening level. In a background music environment, the purpose of the music is to provide ambience. However, songs from different genres, artists, and albums are recorded or mastered at a variety of audio levels. Songs recorded too loud can disrupt conversations, while others recorded too soft might not be heard. For this reason, ALCs are ideal to use with background music systems. An ALC device drastically minimizes these differences, providing more even, consistent levels for a perfect audio ambience experience. ALCs can be standalone devices or integrated as a feature in other audio electronics, and they can be designed to support mono or stereo applications. Here are two ALC product examples. The FP-ALC1 is a mono automatic line level control. It has an input and output on terminal blocks. It has self-adjusting attack and release times, and the automatic gain control has a simple single control setup. You can adjust levels up to 20 dB. The FP-ALC2 is a stereo automatic line level control, has the same features as the FP-ALC1 except both the inputs and the outputs are on RCA jacks. A gate is an effect that turns off or mutes a signal when its level falls below a defined threshold. This muting action is typically called closed, as in the gate is now closed. Signals above the threshold pass through. This action is called open, as in the gate is now open. Gates can be standalone units or integrated into other audio devices. They're also known as noise gates since they're often used to mute unwanted background noise. Placing gates into a municipal environment is a good example of how they could be helpful. Imagine a large room filled with many microphones without gates. In the open position, these microphones would collectively catch and reproduce a tremendous amount of unwanted noise, such as rustling papers, distant chatter, air conditioning or HVAC noise, and more. This collective noise would then be amplified in the sound system. To eliminate this issue, gates could be applied to each mic signal, where the thresholds were set to close the gate or mute the audio signals up through the noise level. When signals above the threshold were present, such as an attendee speaking directly into their microphone, the gate would open. This would significantly lower the overall ambient noise in the room by eliminating it from the sound system. Gates can be used for a variety of different applications and can be designed with several different controls. Here are the more common features. Threshold. Threshold is a defined position where signal levels below this point will trigger the gate to close or mute, and signals above this point will trigger the gate to open or pass through. Attack. This is the set amount of time for a gate to fully open after a signal exceeds the threshold. Hold. This is the set amount of delay or the time the gate remains open after a signal falls below the threshold. An appropriate amount of delay will prevent the natural decay of sounds and/or momentary pauses from falsely triggering the gate to close. Release. Once triggered, the release is the defined amount of time it takes for a gate to fully close from the open position. For example, an ample amount of time could be set to allow the end of a song to gradually fade before the gate closes. Let's review two standalone gate examples. The ST-GLA1 is a gated line level amplifier. Its circuitry is self-gating to suppress unwanted noise. It has fast silent audio switching. It has adjustable gain and threshold and supports balanced or unbalanced line level input and output. It has an open collector logic output to trigger other devices. The ST-GSP1 is a gated speech amplifier. Its circuitry is designed to activate the gate based on the presence of speech. It supports balanced or unbalanced mic level input and has line level output. It has adjustable gain and threshold, and it also has an open collector logic output to trigger other devices. This unit even has a phantom power provision to support condenser microphones. Next, we'll discuss amplification, or the boosting of signals. There are three common types of signal boosting devices: mic preamplifiers, line amplifiers, and power amplifiers. I'll start with mic preamplifiers. Microphones output extremely low-level signals, typically in a range of -60 to -40 dBu. A mic preamplifier, also known as a microphone preamplifier, mic pre, or just preamplifier, is used to boost mic level signals up to line level in order to work with other audio equipment. They can be standalone devices or integrated into various electronics such as audio mixers and DSPs. They're available as a single channel unit or as multi-channel units that usually support either 2, 4, or 8 microphones. Preamplifiers can be designed to provide either a fixed or an adjustable amount of boost, typically in the range of 30 to 60 dB, where some units may boost higher. As very important devices in an audio system, preamplifiers can offer a large variety of controls and features, as well as extensive levels of overall quality. Per channel, these variances result in a broad range of prices, from moderately priced units that are functional entry-level preamplifiers to extremely expensive high-quality, fully featured boutique preamplifiers. Some of the more common features include gain or input gain. This is used to adjust the level of the incoming mic signal. Phantom power, which provides the voltage for condenser mics, commonly offered in 12, 24, or 48 volt DC. Phase reverse, which reverses the phase of a mic signal. Low cut or high pass filter. This removes low frequencies, only allowing higher frequencies to pass. Pad or input pad. This is signal level attenuation or reduction, which is typically provided as -10 dB or -20 dB. Here are several mic preamplifier examples. The Easy MP2A is a 2-channel mic preamplifier. It has XLR inputs with switch selectable phantom power. It has unbalanced output on either mini or RCA jacks, and on the front panel it has a compressor enable disable switch as well as level control for each channel. The RU-MLA2 is a 2-channel mic or line preamplifier. It has XLR and detachable terminal block inputs and outputs. The inputs and outputs are also switch selectable between mic or line level. It has switch selectable mic gain and phantom power and gain trim on each input. The STM-LDA3 is a studio quality mic preamplifier and distributor. It provides adjustable gain up to 60 dB. It has dual LED view metering, selectable phantom power, and as a distributor, it also provides 1x3 distributed line level outputs. We have 2 more studio quality mic preamplifiers available. The HRMP2 is a studio quality 2-channel mic preamplifier. It has balanced XLR inputs, and both channels have independent switch selectable controls for 24 volt or 48 volt phantom with a low cut filter, a 15 dB input pad, and polarity reversal. On the front panel there's gain control that offers 20 to 60 dB of gain with dual LED view meters. It has clip indicators for peaks that are 3 dB below clipping, and the output supports balanced or unbalanced line level out on XLR, 1/4 inch tip ring sleeve, or detachable terminal block. There's also a separate summed output on detachable terminal block. The FP-MP1 is a single-channel studio quality mic preamplifier. It has switchable phantom power and available as either 12 or 24 volt. It has both XLR and detachable terminal block connectivity and selectable input level ranges. It also has an adjustable gain trim with dual LED view metering. Similar to mic preamplifiers, line amplifiers are used to boost line level signals to make them more compatible with other line level equipment, such as when you're combining consumer products with pro equipment. They're also used to boost signal levels to compensate for signal loss over long cable runs. Typically, line amplifiers boost gain levels up to 20 dB. Some may boost higher. They can be designed to support balanced or unbalanced signals and may also offer conversion between these signals. They can be standalone devices or integrated into other audio equipment. These three examples are line amplifiers from our stick-on series. The STA1 is a two-channel line amplifier. Both channels independently offer adjustable gain from -12 to +20 dB. It offers balanced to unbalanced conversion, meaning it has the ability to wire inputs and outputs balanced or unbalanced as needed. You can adjust signals from -10 dBV to +4 dBu, or from +4 dBu to -10 dBV. The STA2A is also a two-channel line amplifier. It has the same features as the STA1, except offers greater gain adjustment from -14 to +24 dB. The STA1M is a monoline amplifier that has the same functionality as the STA1, except with an adjustable gain from -14 to +14 dB. Here are two line amplifier examples from our flat peg series. The FP-UBC2 is a two-channel line amplifier which converts two unbalanced lines to balanced. It has dual RCA jack inputs and dual XLR outputs. This line amplifier is designed to boost -10 dBV consumer signals to +4 dBu professional signals. It provides -5 to +10 dB output adjustment. The FP-BUC2 is a two-channel line amplifier designed to do the opposite. It converts two balanced lines to unbalanced. It has dual XLR inputs and dual RCA jack outputs. This line amplifier is designed to attenuate +4 dBu professional signals to -10 dBV consumer signals. It provides -6 to +6 dB output adjustment. These two line amplifiers have unique features. The RU-AFC2 is a 4-channel line amplifier and bidirectional format converter. The first half is used to convert two unbalanced lines to balanced. It has two RCA jack inputs with individual gain adjustment. It's used to increase signals from -10 dBV to +4 dBu. Its +4 dB output has an adjustment from -25 to +9 dB. It has XLR or terminal block outputs plus a sum mono output. The second half is used to convert two balanced lines to unbalanced. You have two XLR or removable terminal block inputs. This unit is used to decrease signals from +4 dBu to -10 dBV. The -10 dBV output has gain adjustment from -25 to +5 dB. It has RCA jack outputs with individual gain adjustments. The FP-UBC6 is a 6-channel line amplifier. This unit is designed to convert 6 unbalanced lines to balanced. It has RCA jack inputs and XLR outputs. It's used to increase signals from -10 dBV to +4 dBu. The +4 dBu outputs have a gain adjustment from -5 to +10 dB. This unit is great for surround sound applications. A power amplifier, also known as audio amplifier, or just amp, is a circuit used to increase the voltage and current of a line level signal in order to power loudspeakers or headphones. A variety of amplifier types and power levels are available to support many different needs and applications. An amplifier can be a standalone piece of equipment or integrated into other devices such as audio mixers, loudspeakers, and consumer electronics including home theater equipment. As we discussed earlier, they can be designed to produce either low impedance or constant voltage signals. Power amplifier circuits can be designed in a variety of ways called classes. There are 5 major classes or categories called Class A, Class B, Class AB, Class C, and Class D. All classes of amplifiers offer unique qualities and benefits. However, because of the many differences and variables available, covering this topic would be too lengthy for this presentation. In brief, most RDL amplifiers and headphone amplifiers are Class D, which was chosen for its extreme efficiency, its low heat and light weight compared to other classes. Here are some stereo power amplifiers. The TXPA40D is a 40 watt stereo audio amplifier that provides 2 × 20 watts into 8 ohms or 2 × 15 watts into 4 ohms. It has selectable stereo or sum mono operation. It supports unbalanced inputs on RCA jacks with individual gain control. It has our auto-adjusting compressor limiter, and the power supply is included. The RUPA40D is a 40-watt stereo audio amplifier with a VCA feature. It has the same features as the TXPA40D, except it has a VCA control for external remote level control operation. The EasyPA20 is a 20-watt stereo audio amplifier that provides 2 times 10 watts into 8 ohms or 2 times 8 watts into 4 ohms. It has unbalanced RCA jack inputs with gain control, a built-in overload limiter, and the power supply is included. Here are 2 constant voltage power amplifiers. The FBPA35A is a 35 watts constant voltage amplifier that provides either 25, 70, or 100 volts output. It has our auto-adjusting compressor limiter circuitry and an automatic energy-saving sleep mode function. Sleep mode is a standby operation that uses very little power when engaged. The unit is placed into sleep mode whenever there's an absence of an audio signal for a select amount of time. The absence of a signal starts a countdown timer which has a selectable amount of time before it engages this standby activity called sleep delay. The sleep delay can be adjusted to 5, 15, or 25 minutes, or it can be turned off. The amplifier restores to full operation whenever a signal is detected. The unit supports balanced or unbalanced line level inputs and provides gain control. It's also plenum rated, meaning it can be installed in a plenum area, and the power supply is included. The SFPA50A is a 50 watts constant voltage amplifier that provides either 70 or 100 volts output. It supports a balanced mono input on terminal block or an unbalanced stereo input on mini jack. It has adjustable gain and a VCA control provision for optional external remote level control. This amplifier is also plenum rated and comes with a power supply. Here are some power amplifiers from our stick-on series. The STPA2 is a 2 watts utility power amplifier. It provides 2 watts mono into 8 ohm and 600 ohms simultaneously. It has an unbalanced input with gain control, and it's ideal for use with intercom or music on hold systems. The STPA6 is a 6 watts mono audio amplifier. It has 2 balanced or unbalanced summing inputs, adjustable gain control, and adjustable bass boost EQ. The STPA18 is an 18 watts mono amplifier. It has our auto-adjusting compressor limiter, balanced or unbalanced line level inputs with gain control, and it has a loop out feature to connect to additional amplifiers or other products. These 3 amplifiers are from our flat pack series. The FPPA18 is a mono audio amplifier that provides 18 watts into 8 ohms. It has our auto-adjusting compressor limiter, our automatic energy saving sleep mode with an adjustable sleep delay that can be selected to off, 5, 15, or 25 minutes. It supports balanced or unbalanced line level inputs with gain control, and the power supply is included. The FPPA20 is a mono audio amplifier that provides 20 watts into 8 ohms. It also has our auto-adjusting compressor limiter, supports balanced or unbalanced line level inputs, and has front panel gain control. And the FPPA20A is a 20 watts constant voltage amplifier with either 70 or 100 volts output. It has our auto-adjusting compressor limiter, supports balanced or unbalanced line level inputs, has the front panel gain control, and this unit is plenum rated. And here are some examples of our mixer amplifiers. The HDMA35UA is a 35 watts constant voltage mixer amplifier that provides either 25, 70, or 100 volts output. It has a 4-channel mixer with 2 balanced microline inputs on terminal blocks and 2 unbalanced line inputs on dual or stereo RCA jacks. It has a Vox or priority ducking feature for paging and music on hold applications, and this feature can be set up to be operated manually or automatically. It has our automatic energy saving sleep mode function, our auto adjusting compressor limiter, a VCA provision for optional master volume remote level control, and it has bass and treble tone controls on the front panel, plus the power supply is included. A quick note, there are 10 different models of HD series amplifiers available. The Easy MXA20 is a 20 watts stereo audio mixer amplifier. This unit provides 2 times 10 watts into 8 ohms or 2 times 8 watts into 4 ohms. It has 3 inputs, 1 XLR mic, and 2 stereo RCA jacks. It has switch selectable phantom power, bass and treble tone controls, and a built-in overload limiter, plus the power supply is included. Remote controls are simply separate panels or devices that contain adjustment knobs, faders, buttons, or similar that provide the primary control functions of a particular device, such as a mixer or a switcher. These remote controls are installed or placed away from their primary devices for convenient control access, or maybe for aesthetics where seeing the primary unit is not desirable. Often, primary devices need to be installed in an equipment room, or a communication or comms room, or up in the plenum space, yet functional control needs to be easily accessible. The first remote control I'll review is for level or volume control. Most manufacturers traditionally design their products using audio taper pots or volume knobs that directly raise or lower the audio signal levels. RDL offers a superior method through a circuit called Voltage Controlled Amplifier or VCA. Like volume knobs, VCAs are typically used to adjust audio signal levels for a range of needs from the input of a single device such as an audio recorder to the overall volume level of a sound system. A VCA may be a standalone module or as a component built into a particular device such as a mixer or amplifier. So how do they work? First, VCAs use voltage as a control signal, so only voltage passes through the adjustment knobs or push buttons, not audio. The VCA's control circuitry sends full voltage to the knobs or buttons located on the device itself or to a remote control, where a user can adjust the voltage level that is returned back to the VCA. This varying voltage level directs the VCA to increase or decrease the audio signal levels through its solid-state circuitry that has no moving parts. Conventional audio controls have moving parts that break down over time, which can add noise to the signal and degrade the adjustment quality of the control itself. Here in this example, we're showing RDL's ST-VCA3 voltage controlled amplifier, a standalone unit that's designed to add level control to any audio device that doesn't have adjustable volume. RDL products primarily use 10 volts DC as control voltage. If the VCA receives a full 10 volts back, the audio signal will be raised to its highest level. As the voltage is decreased or attenuated, the audio signal will be lowered until it's essentially turned off. Here's the advantage. Again, conventional audio pots or volume knobs are different in that the actual audio signals pass through them directly. They have 2 primary components, a fixed resistive element and a sliding contact wiper that contact each other. By turning the knob, the wiper slides along the resistive surface from one end to the other, which adjusts the audio signal level. However, these contacts are subject to wear and carbon buildup, which can greatly affect the audio signal quality during level adjustment, typically by producing audible pops and crackles or sudden jumps in signal levels. Since audio signals do not pass through VCA controls, the audio of the signal is never degraded and level adjustments will remain accurate and smooth for the life of the product. Here are some single-channel VCA remote controls. The DRLC10K is a single-turn remote level control that contains a high-quality 10 kiloohm potentiometer for adjusting control voltage. This remote can be wired directly to any of RDL's VCAs. The DRLC10KM has the same features, but adds a mute function with an LED indicator and an RJ45 port for direct control of select RDL modules using standard Cat5 cable. The DRLC3 has 3 selectable levels plus off, where the levels are adjusted by the installer. The DRLC2 provides 2 momentary push buttons that provide up-down level operation and has a 10-segment LED display. This unit is designed to work with RDL's ramp generator circuitry, which is found in select RDL products. Single or multiple controls can be wired together, which will provide synchronized level control and display. The DRLC10 is a rotary remote level control with a 10-segment LED display. This unit also utilizes RDL's ramp generator circuitry and can be used at single or multiple locations. Up to 10 remote controls may be wired together, which will provide synchronized level control and display. The DRLC10M has the same functionality as the DRLC10, but adds a mute function with a separate LED indicator. These VCAs are remote audio mixing controls. Available in 2 or 3 channels, and with or without separate mute buttons, they duplicate the primary level control of select RDL mixers. These particular remote controls include RJ45 ports for connecting with a standard Cat5 cable. This makes the installation quick and easy. The DRC2 is a 2-channel remote mixing control. The DRC2M has the same functionality, but adds 2 individual mute buttons with LED indicators. The DRC3 is a 3-channel remote mixing control, and the DRC3M has the same functionality, but adds individual mute buttons with LED indicators. Here we have 2 examples of our remote-controlled mixers. The FP-TPX3A is a 3-channel mixer. The levels of all 3 channels can individually be adjusted with the DRC3M 3-channel remote audio mixing control with muting. The second example is the HDMA35U 35-watt mixer amplifier, which provides 4 channels of local mixing. However, its master volume can be remotely controlled with a DRLC10KM level control with muting. All 10 HD series amplifiers and mixer amplifiers have a VCA level control feature. And last, we have remote switching or channel selection. These are essentially remote panels that duplicate the push buttons or similar controls of a switcher. These remote controls allow you to select between multiple audio sources. The DRC4M is a 4-channel remote control designed to provide source selection at a single or multiple locations. Up to 10 units can be wired together. It has 4 LED indicators that brighten momentarily when a button is pushed, then dim their intensity to avoid being a visual distraction. The DRC4ST is a 4-channel remote control for directly controlling an RDL ST-SX4 audio switcher. 2 ST-SX4 switchers may be controlled simultaneously for stereo operation. The DRC4RU is a 4-channel remote control for directly controlling several RDL rackup switchers, such as the RU-SX4A audio switcher. The DRC-S4 is designed to specifically control the RU-SX4A audio switcher, but allows for a single or several controls to be wired together for multiple control locations. Consult each product's specifications for more details. Here's an example of an audio switcher being remotely controlled. The DRC4M 4-channel remote control is directly wired to the RU-ASX4D 4-channel stereo switcher. In a real-world application, the switcher could be rack-mounted in an equipment or comms room, or table-mounted in some secluded area, and the remote control could be installed in a conveniently accessible location and/or aesthetically pleasing location. I'm sure you can see the great benefit our remotely controlled products provide. At this time, I would like to point out that RDL produces all steel cover plates for our decor-sized remote controls and other decor products. These cover plates are available in 1 through 4 gang sizes in white, black, brushed stainless steel, and gray. Due to the wide variety of choices, these cover plates are sold separately. Although RDL produces Dante network, Bluetooth, and digital audio products, no matter how modern the design is, all systems from any manufacturer will start and end with analog circuitry, as that's how humans interface with audio. We cannot speak or hear digital code. And to effectively and properly design these systems, separate, standalone analog products will need to be included. RDL offers many more products than those reviewed in this presentation, but the products and information I've shared will provide the right tools you need for any system design. Last, I want to take a moment to show you how to find these and all of RDL's products quickly and easily. Our website, www.rdlnet.com, is designed to help you effectively search and find products in several ways. You can search by model number. If you know the model, simply type it in the search field located in the upper right side of the home page. The more characters you type, the more narrow or specific the search becomes. Another option is to click on the Products tab located in the top header. Here you'll find an option to search alphabetically, see our new products, and search by categories such as audio or switching and control. Or you can click on any subcategory such as microphone products, power amplifiers, or remote controls. You can also search by product series in the bottom section by clicking on Flat Pack, Rack Up, or Stick-Ons, for example. Clicking on any of these options takes you to the next search level page. And here, you can scroll up or down to find the specific products you need. And for system design ideas, click on the Application tab located in the top header. Here, all of our application drawings are divided into 12 separate categories, such as background and foreground music, boardrooms, education, healthcare, and more. Clicking on any of those categories brings you to a list of designs. Just like with a product search, simply scroll up or down until you find a design you like, then click on one to select it, and it will expand to full screen. Each of our application drawings provide full system descriptions, wiring, and the specific RDL product models and the quantities used, which is all listed at the bottom. Please know, even though you found a specific drawing in one category, that design may easily be applied or adopted to multiple industry applications. And that wraps up this presentation. Be sure to see all of our product training modules located on our website homepage under the Reference tab. We hope you found this information helpful, and we appreciate you taking the time to learn about analog audio basics and RDL's analog products. Thank you.